Anybody else have a robot to show tonight? I see one right here. Is that yours
Locomo
again?
mapping.
Okay.
Sure.
Speaking of Ross.
This is Locomo. Locomo's a smart table. The concept is a table that can get from one place to another and back again in an unstructured environment. I'll drive them around like I'm doing now and create a map. This is based on the Vorwerk VR100, which is a variant of the Nito XV robot, but everybody's building their robots with the Nito robot, be it XV, BotVac, whatever. They all feature the LiDAR, two-dimensional LiDAR, that allows you to navigate specifically. All of us is built bump around and obstacle avoidance robots over and over and over again. But here you actually have a robot. Can you see that okay?
Yeah. Set it down.
Yeah, okay. No, that takes too long. But regardless, here I've made this map, and we're Angels Fear to Tread live demos. Hey Ryan, good to see you, man. I shall save the map.
Where is the LiDAR sensor?
Good question. When you look at a Nito robot, do you have the BotVac here? There's a turret at the top, and it's basically a single laser and an imager, and it spins. It spins at 5 hertz. Okay, and it takes 360 readings per revolution, and can thereby discern obstacles in 360 degrees.
Okay.
And you plug that into the stuff that is ROS, and that gives you the ability to map and then navigate. It gives you this beautiful visualization tool called a ROS Visualizer, okay, RViz. It's a standardized means of logging through ROS bags and standard means of distribution through GitHub. So I'm I'm saving the map that I just made. Be sure and save the map. Thank you. Be sure and save the map. I'll just say it that way. Bear with me here. Everybody's laughing because, okay, here the map is now saved. I'm going back to G mapping, grid mapping. This is the routine in ROS with which you create this map, which I've now saved. And you go to the navigation stack, which loads in 2 programs, MoveBase and something called AMCL, Adaptive Monte Carlo Localization. Bear with me. Oh, Ralph Knock, is he here?
No, he's still down.
Ralph Knock is, Mike Ferguson originally wrote the BotVac package, and Ralph did work with it in conjunction with Ubiquity, I believe. But regardless, they put it in the launch files and stuff like that and made it a lot easier. So tip of the hat to Ralph, wherever you are out there.
He's in Australia.
Went home, did he? Aye. Okay, so here we are. I'm running the mapping and the navigation on the remote workstation. One could run it on the robot or the remote workstation. I just run the base and master on the robot, and I'm doing mapping and navigation on this remote workstation. But again, you can do it either or, and very, very flexible. Bear with me. So now I'm copying, Control-C.
Do we have a hookup to this?
Okay, this will be brief. Okay, so now I've copied in that, and bear with me. This is starting to get real exciting.
Can you put it on the table? The camera's zoomed in to the table.
Okay, here, cool.
Just rest it on the table. I zoomed in, so.
There you go.
Now we see his best side.
All right, bear with me once again. Okay, so here's your map, and this is the terminal in which the G mapping is running.
Does it recognize obstacles on its own?
Yes. Again, first you do mapping where you're creating the map. It recognized it saw the obstacles in order to create the map, right? So now, having saved the map, see like this? I mean, this is, oh, bear with me, this is kind of nice.
For those who haven't been in this room, if you look on the right screen, it'll be non-mirrored. So, because if you look on the left, it's even more confusing.
What did I just, oh, okay, come on. Come back. Oh, you stupid. What did I just do?
Did you save your map?
I did save the map, but I clicked on something and it's not happy at all now.
Is that new to this room?
Things were going a little too well. Regardless, I drove around, I made the map. If it were going right, Control. What's the screen thing?
Take your time, Cam.
Yeah, I'm done. Regardless, if I'd say that I could click the other side of the room and the robot would have navigated to there autonomously, avoiding obstacles and so on and so forth. One of the things about this and one of the great things about Ross is you can do the bot vac package and it's well enough as is, but you can make new robots by appending it. That is, I've added the Arduino and 2 ultrasonics, and the concept here is the robot's running the bot vac package, which will do mapping and navigation by itself, but I have to look out for an additional 2.5 feet. So I plug in an Arduino and 2 ultrasonics, and when I'm navigating, the ultrasonics come online to keep the robot from going under the bed and under the couch and stuff like that. So this is, go ahead.
Now that you have moved the robot from the spot where you picked it up, does it know the new location? And can
Yes,
it
that's the
find-
kidnapped robot program, no. But within RViz, one can reset the pose. In other words, the visualization program, you saw where it represented where the robot was, and I pick it up and I move him to the other side of the room.
Yeah.
The robot doesn't know where he is. But on the map, I can reset the pose. I have to do it. I have to set the pose on the map.
He can say.
I can tell the
your
robot where he
robot
is.
Right here now. That's
So it's
what pose
loca-
is.
Okay,
location and orientation.
But Ross has the ability to.
but it doesn't know which way it's facing.
But Ross
That's
can
part of the pose.
do the
That's part of
figure
the
out
pose
some of
is
the kidnapping
location
for you
and
and sending out part of it.
So that's-
Yes, but I can't. Not currently, anyways. Yeah, okay, very fine, thank you, sorry about that. Arrgh, it was going so well, too.